Now, in this video, we're going to look at a few more examples about breaking up chains and the different enzymes. Example 4. How many chains are there so that under G enzyme is broken into CCG, G, UCCG, AAG, and under UC enzyme is broken into CCGGU, CCG, AAG. If you watched the previous video, this is just a combination of example 2 and example 3, and we want to consider these two cases together. If not, simply we want the number of chains that can be broken into these subchains and the G enzyme, and we found out that the number of them is 4 factorial because we're simply reordering these 4 subchains. And then under UC enzyme, we want the chain to be broken into these 6 subchains, but the number here is no longer 6 factorial because this particular subchain has to be at the end. It doesn't have URC at the end, so it has to be at the end of the original chain. And then we're simply reordering the remaining 5 subchains, which turns out to be 5 factorial divided by 4 factorial, because we have 4 identical C's, and this turns out to be 5. So we discovered that the number of chains and the UC enzyme that can be broken into required 6 subchains, the choice is only 5, and we can write them all out. For example, remember this block is always at the end, so we are simply reordering 4 C's and 1 GGU. So we could have this particular chain that will be broken into this 6 subchains and the UC enzyme. Now it's time for us to check, would it be broken into these 4 subblocks and the G enzyme? So, and G, so that's a question mark. If we apply this G enzyme, we find that this chain is going to be broken into CCCCG, G, UG, and AAAG. And if you go back to check what we want, this is simply not, it is not going to work. And then how about the next choice we might have? Remember, we have 5 choices here, so in theory, we could write it out. We could just list them all out. Okay, so here's the second possible choice, and then we can check again. Under G enzyme, what would we get? We will get CCCG, G, UCG, AAG. Would this work? Well, the answer is no, it's not going to work because we need a subchain that's of the shape CCG, and we don't have it here. And you can continue doing this. So the third possibility we would have is CC, GGU, and C, and then apply G enzyme again. We would have CCG, G, UCCG, AAAG. And this is exactly what we want. So this will work. How about the next one? We'll just leave them all out and see how many of them would work. So we would have CG, G, UCCCG, AAG. This apparently is not going to work because we don't have the subchain UCCCG. And we are left with the last choice when GGU shows up first. C, 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 C. And then you apply G enzyme again. You would have G, G, UCCCCG, AAG, and this again is not going to work. So it turns out, how many chains are there so that under G enzyme is broken into the required subchain and under UC enzyme is broken into the required subchains? Only one choice, which is right here. Next, a very similar question. Let's look at example 5. Suppose there's an RNA chain with the following decomposition. So here's what we want under G enzyme, 1, 2, 3, 4 subchains. Here's what we want under UC enzyme. We have 1, 2, 3, 4, 5 subchains. Let's answer these questions one by one. How many different chains have the same number of A, U, C, G? Well, let's first count. How many A's are there? I see 1, I see 2. So we have 2 A's. And how many U's are there? I see 1, 2. So 2 U's. How many C's are there? I see 1, 2, 3. 3 C's. And lastly, how many G? 1, 2, 3. So 3 G's. So in total, how many elements or how many bases are there in total? There's 2 plus 2 plus 3 plus 3. That's 10. So the total number of different chains using the same number of AUCG is going to be 10 factorial divided by 2 factorial, 2 factorial, 3 factorial, and 3 factorial due to the identical elements. That's part 1. Part 2. How many chains have the same G fragment? So G fragment, we want, under G and M, we want G, we want U, we want ACUG, we want CACG. The question here is it 4 factorial? The answer is no, because if you observe, this particular subchain does not end with G, so it has to be at the end of the chain. So in fact, we are only reordering the other 3 subchains. So the answer here is 3 factorial, which is 6. Okay, part 3. How many chains have the same UC fragments? So let me write them down. We have U, we have AC, AC, GU, GGC. So is it, let's see, we have 1, 2, 3, 4, 5 blocks. And then we see 2 repeated subchains, so divided by 2 factorial. Is it 5 factorial over 2 factorial here? The answer is yes, it is. Because each one of the subchains can be anywhere. They either end with U or end with C. So we don't need to worry about the case in the second part, in fact. So it's simply 5 factorial over 2 factorial. That's 60. Okay, 4. We want to combine now in the second part and third part. How many chains have the same G and UC fragment? Well, in this question, I think it's better for us to list all the possibilities in part 2 because we have less choices there. So let's do that. And remember, G always shows up last. So, sorry, U always shows up at the last. So U is here. And then we are going to be reordering G, ACUG, and CACG. So G, ACUG, CACG. Case 1, or G, CACG, ACUG. Case 2, or ACUG, G, CACG. Case 3, case 4, case 5, and case 6. Now, under UC enzyme, we're going to check these chains one by one to see whether we will get our sub chains under UC enzyme. And you can do that on your own. You'll find out that in the end, only the third possibility here would give us the required subchains under UC enzyme. All the rest will not work. Please try to do this on your own.